Hi, welcome back to my channel. In this particular video, we're going to look at how to write a linear programming problem in a standard form, right? And if you're new to this channel, my name is Abdul Wahab, and I make videos on maths problems related to undergraduate maths courses. So if it's sort of thing that you would enjoy, please do subscribe to this channel and like the videos as you go through. There are so many playlists that I have on this channel, so you can go through them and find those that are useful to you. Now, let's just get right into this problem. So we have this an optimization problem, and we need to rewrite this in standard form. So basically, these equations need to be written in a different form. Now, what we need to pay attention to is this variables, right? Because in a standard linear programming problem, what we have to do is to make sure that all the variables are greater than or equal to 0. So you want to make all the variables as well as the slack variables should all be greater than or equal to 0. So this is how we generally write the LPP in standard form. Now let's pay attention to those variables. So first one, x1 is greater than or equal to 0. So this is good. We have no problem with this, but we need to work with this, right? X2 is greater than or equal to P. Now we can rewrite this as what? X2. So we kind of add a slack variable on the right-hand side. So X2 will now become P plus some X2 prime, right? Where X2 prime will be greater than or equal to 0. Okay, this is good. Now notice that once you have this, you need to now replace X2 with P plus X2 prime, right? In the other equations. Now, what about X3? So X3 is the tricky one. This could be positive or negative, right? So we would rewrite this as the difference between two positive numbers, right? Two positive real numbers. So we can write X3 as this, where if X3 is positive, that means this will be higher than this. If X3 is negative, that means this will be higher than X3 plus. So both of this will be greater than or equal to 0. So this is what we really need to do. Then the rest of the work is just a substitute, right? So for the first one, Z is X1 plus 2X2. So what is X2 now? P plus X2 prime minus X3, which is X3 plus minus X3 minus. So what we have now is what? X1 plus 2P plus 2X2 prime minus X3 prime plus X3 minus. This is X3 plus, sorry. So we can rewrite this as, it doesn't take a genius to do this, right? So this is the first one. Now let's look at the second one, the constraint. So the constraint, the first one is X1 plus X2. Remember what X2 is. Minus X3. So basically the same thing. Then you need to add a slack variable. So remember we have less than or equal to. So the slack variable will be on the right left-hand side as positive. So plus S1 equal to 5. Okay. All right. So we can rewrite this. So I would like to put a box around the solution. So now what do we have here? We have X1 plus X2 prime minus X3 plus X3 minus plus S1 equal to 5 minus P. So this becomes the second one, right? Cool. Now let's move to the third one. So move to the right-hand side. Now on the third one, so what's the equation? So for the third one, we'll have minus X1, good, plus 2X2, which is P plus X2 prime, plus 3X3, which is X3 plus X3 minus, greater than or equal to minus 4, which means we need to put our slack variable would have a negative sign, right? Because if we were to put it on the right-hand side, generally we could write it as this minus 4 plus S2, okay? Right, because we have the greater than sign. So that means minus 4 plus an additional variable, right? A real number, S2 being a real number, right? Which is non-negative. So if we bring the S2 to this, to the left-hand side, we'll definitely have this, right? So let me just rewrite it properly. Now we can expand this to give us 2p plus 2x2 prime 3x3 plus minus 3x3 minus s2 equal to minus 4. Now we can multiply everything through by minus. So multiply everything through by minus 1, multiply everything through by minus 1. We now change the sign to x1 minus 2p minus 2x2 prime minus 3x3 plus 3x3 minus plus s2 equal to 4. So rewriting this for the last time and taking 2 minus 2p to the other side, I have this. It takes a while to write this. It's a lot of writing. 4 plus 2p. Okay, good. So this is the third one, right? Now, what about the fourth one? So what's the fourth one? So the fourth one is 2x1 plus 3x2. So this is p plus x2 prime minus 4x3, which is greater than or equal to 3 again. We have minus s3 equal to 3, right? So this is what we have, okay? So now we need to simplify this again. So let's expand. So rewriting finally, we're taking 3p to the other side. We have this. Okay. Good. Now, I think we're in the fifth one, which states that what x1 plus x2, which is p plus x2 prime, plus x3, which is x3 plus minus x3 minus equal to 2. Okay, so if you rewrite this, you just basically have this 2 minus p. Okay, very good, very good. Now, finally, is the variables. X1 is greater than or equal to 0, and then we have x2 bar, x3 plus, x3 minus, all greater than or equal to 0. So that completes the formatting this problem into the standard format, right? So this is the standard form. We have this optimization of Z with respect to these constraints that we have highlighted with the boxes. Now, the final problem is, what is the constraint, or what is the range for P? So we are looking for the range for P. Now, how can we find the range for P? We can use this, this standard form to be able to do that. So we look at each of the equations, right? And from each of the equations, we can determine what would be the range for P. So think about the first. So let's look at this second equation, right? So when we look at this second equation, we can see that if P was on the left-hand side, that means that everything plus P would be equal to 5. So which means that P must definitely be less than or equal to 5, right? So we have some things here. We don't know what they are. X1 plus X2 bar and so on and so forth, plus P is equal to 5, right? So, and notice that, so because of this relationship, we know that whatever we are adding to P, we know that somehow P would be less than or equal to, P would be less than or equal to 5, right? When we take a look at the possibilities, so we'll basically check these conditions to see which constraint or or which range works for P. So basically we look at P less than or equal to 5. So let's just come to the right-hand side and write everything down. So the first one, we look at P less than or equal to 5. For the second one, for this particular one, what do we have? Something similar. So think of minus 2P to be on this side of the equation. That means minus 2P will be less than or equal to 4. And then for the third one, we'll have 3P. So if you take this to this side, it will be 3P plus something else, right? Equal to 3. So that means 3P will be less than or equal to 3. So this is the condition we're looking at. And then finally, we have take P to the other side. You take P to the other side, so you also have P less than or equal to 2 for the last one. So when you look at all these conditions, this gives P less than or equal to 5. This gives P greater than or equal to minus 4 over 2, which is minus 2. This gives P less than or equal to 1, and this gives P less than or equal to 2. Now, when you see P less than or equal to 5, less than or equal to 2, less than or equal to 1, so this is the condition, P less than or equal to 1. So when you look at the constraint, right? So basically, we're going to have minus 2 less than or equal to P. So for the upper bound, this we should pick 1, right, instead of 2 or 5, right? Why is that the case? Because we need to pick the smallest region, right, where P will satisfy. So this gives us the range for P. And that completes this video. If you have any question, please comment down below, and then we can have more discussion on this particular problem. I agree that this problem is a little bit long, but you know, you can pause the video and then watch it over and over again to get a grasp of the concept and how I approach this problem. So I'll see you guys in the next video.